Welcome back to Sustainably Influenced. I'm your host, Bianca Foley. In this season, we're discussing the relationship between the tech space and sustainability. Technology has the power to revolutionise the way we live and do things, and this has never been more important than in the current climate crisis. In recent years, the world has faced increasing challenges related to global warming, loss of biodiversity, and resource depletion. However, technology has the potential to provide solutions and mitigate the impact of these problems. Advances in areas such as renewable energy, energy efficiency, sustainable transportation, and smart cities can help us to transition to a more sustainable future. As businesses set ever more ambitious environmental, social, and governance goals, their sustainability and technology strategies need to become more tightly aligned. Over the course of this season, I'll be diving into these strategies, speaking to disruptors and free thinkers in the industry who are using technology-based solutions to combat the climate crisis. Welcome back to another episode of Sustainably Influenced. In today's episode, we're discussing an area that I haven't touched on before on this podcast. A little bit nervous, but I think it'll be a good episode. Just to put it into some perspective, I really love science, and Charlotte, my former co-host, would describe me as a bit of a nerd, and she loves that about me, I hope. But I really get excited about, and I've said this time and time again, I get really excited about innovation, and I love when people are using their brains and using anything that they can and seeing that problems can be solved and making solutions out of things that are sometimes just everyday things. And yeah, so anyway, if you're a long-term listener, you'll know how much I love innovation, and I have genuinely squealed at some of our incredible guests that we've had over the years. I always wanted to work in the field of genetics or medicine, but just never pursued it. But science still has a huge place in my heart. So when discussing episodes for the season with my producers, I was introduced to today's guests. And I have to say, today's episode is very factual, but I hope that you'll end up feeling as inspired as I was from the conversation. We always discuss ways to make production more sustainable, but we rarely discuss what it takes to make that actually happen. Scientific innovations play a crucial role in promoting sustainable living by creating new technologies and improving existing ones that help to reduce the negative impact of human activities on the environment. I wanted to highlight some of the ways that scientific innovations are helping sustainable living. Here are a few kind of ways from my research that I found. So we've got like renewable energy, energy efficient buildings, sustainable agriculture, recycling and waste reduction, transportation. I mean, let's look at renewable energy in a little bit more detail. So the development of renewable energy technologies such as solar, wind and hydropower has actually enabled people to reduce their reliance on fossil fuels, which is amazing, and it's a huge benefit of that. And they're major contributors to greenhouse gas emissions. So these technologies are also able to help us reduce our air pollution and negative impact of climate change. And we're going to be speaking about air pollution in a later episode, actually, so make sure that you're subscribed and listening to that. Energy efficient buildings, however, when I was reading up on this, I thought, oh, wow, I didn't know that and I didn't think about that. So it's been quite interesting for me. Advances in materials science and engineering have led to the development of energy efficient buildings, materials and design. These innovations can help reduce the amount of energy needed to heat and cool buildings, which helps to save energy and reduce greenhouse gas emissions. So for those of you working in an office block that has like climate control, think about it that way. I just found it really interesting because these are things that we don't even consider unless we're the people working on it. So in terms of agriculture, which again we'll be talking about in a much later episode on this season, scientific innovations in agriculture such as precision farming and genetically modified crops can help to reduce the environmental impact of agriculture while also increasing productivity. So for example, precision farming can help farmers use water and fertilizers more efficiently, while genetically modified crops can be designed to be more resistant to pests and diseases, reducing the need for pesticides and herbicides. Now, I know that that's quite a controversial kind of topic when it comes to fertilizers, but they can be used for good. Innovations in waste management, such as recycling tech and like composting, can help us to reduce the amount of waste generated by society, whilst also reducing the negative impact of waste on the environment, which is a huge bonus. Transportation, we all know advances in transportation tech, such as electric cars and more public transportation, can really, really help to reduce greenhouse gases. And these innovations also help to reduce air pollution and the negative impact of traffic congestion on the environment. So I think we can all agree that scientific innovations are critical in the effort to promote sustainable living by providing solutions to some of the environmental challenges we face every single day. Next up, I want to highlight a few companies who are using science for good. So there's one company called Carbon Cure Technologies, and this startup is using science to help reduce carbon emissions in the construction industry, which is wild to me, because when you look at how labour intensive and the amount of raw material that the construction industry uses, to be able to reduce carbon emissions in that is fantastic. So Carbon Cure Technologies have developed a technology that injects carbon dioxide into concrete during the production process, which not only reduces the amount of carbon dioxide emitted during the production process, but also improves the strength and durability of concrete. Mad. Opus 12, this is another startup, and they're using science to capture CO2 emissions and convert them into valuable products. So Opus 12 have developed a technology that uses renewable energy to convert CO2 emissions into chemicals and fuels. Pivot Bio is another startup who's using science to reduce the amount of synthetic fertilizers used in agriculture. And Pivot Bio has developed a technology that uses microbes to help crops access more nitrogen in the soil, which reduces the need for synthetic fertilizers and the other associated emissions. Now, I know that one's probably a little bit more sciencey, but I think that's really cool to be able to access more nitrogen in the soil, which is just fantastic. There's another couple here that I wanted to just mention. So you've got, I can't say it very well, but Gravitricity, I think, Gravitricity. This startup is using science to store renewable energy. They've developed a technology that uses pulleys to store energy generated by renewable sources, such as wind and solar power. And the stored energy can be released when it's needed to help balance the energy grid, which is so cool. Finally, Lilac Solutions. This is another startup looking to improve the efficiency of lithium mining, which we know is really harmful to the environment. And it's a critical component, actually, in the production of batteries for electric vehicles and renewable energy storage. So Lilac Solutions have developed a technology that uses ion exchange to extract lithium from brine, which is more environmentally friendly and effective than traditional mining techniques. Wow. Another company that I wanted to mention, and it's because they're my guest today. So another company that's making changes and making the use of scientific innovations is Amphico. Amphico is a material innovation startup developing bio-inspired and circular material technology to disrupt the water sport and outdoor high-performance sportswear industry. You guys knew I had to get some fashion in there somehow. This is a tech season, but I had to get that fashion in. They're a combination of experienced scientists and designers, and they're also based in the same area where I record, so in Makerversity. They are a combination of experienced scientists and designers passionate about making the future a better place, both in creating a more sustainable future for the planet and in the improved performance and experience of the products that they create. Today, I'm joined by Dr. Deana Tsang, CTO, and Fergus Telfer, design engineer. Hi both. Could you first of all tell me what it is that Amphico does, maybe provide an overview for us?
Well, first of all, thanks for having us on, Bianca. It's nice to meet you. I'm Fergus. This is my colleague, Deana. Yeah, Amphico is a young material innovation company. We're based here in London. At the moment, we operate out of Makerversity in Somerset House. The company started back in 2018. Our founder, June Camille, studied innovation design engineering at the Royal College of Art. His background's in applied chemistry. So his original project was the development of an artificial gill, so a bit of diving apparatus to allow humans to breathe underwater. And his background in material science and chemistry led him to research and investigate how a polymer that's both hydrophobic and breathable could be manufactured into that device. So that R&D was a couple of years. And along the way, looking into, like I said, hydrophobic and breathable polymers, he identified that actually this could solve a problem in the textile industry as well, particularly around sustainability issues. So we set about developing what we now know as Amphitex, and that's a waterproof and breathable textile that's been designed for the outdoor industry by Deana and her team. Yeah, and that's where we're at on our journey at the moment. We're at the moment 7 employees, and we're really, really excited about the textile we've created. The Gill is still an ongoing project, and that exists sort of symbiotically within the company with the textile project as well. And we're a combination of designers, scientists, and engineers, and the team's only growing. So yeah, it's really exciting.
I think describing ourselves as like a material innovation company is pretty good because we're not really focused on specific applications necessarily. It's just using a set technology and trying to see where it would fit in and how it can improve existing systems. So yeah, that's pretty much what we do.
I was doing the research to include you in another episode I'll have on the season. But when I was sitting there and I was doing the reading, I said, this is so interesting as a completely standalone thing because there's nothing else within this whole area of research that I've looked at that is anything like this. So I found it really exciting when I was doing the research. I mean, I'm not going to pretend that I know anything about it. So if you wouldn't mind, like, if you do use any scientific terms, to just explain them a little bit for myself and our audience, and to just get a little bit more of an idea about what it is that Amphitex is and maybe why it's better. So how do you ensure that your products are designed for longevity and repairability so that they can be used for as long as possible, promoting that more conscious, sustainable kind of way of consumption with them?
Yeah, that's a great question. I think we tend to take quite a few different approaches to sustainable textiles. It's quite a big umbrella term, so you can approach it from lots of different ways. But for us, particularly in terms of longevity and durability, the key thing about our textile is that with a lot of waterproofs or water repellent garments and the materials used to make them, they have to be coated with an extra layer and an extra chemical. And it's just an added process that gets put into the mix of how you manufacture the whole fabric. For us, we don't rely on that. We're using like the inherent material property itself. So we don't have to do that extra coating process. And because you're not relying on anything on the surface, like a coated surface, it won't wear off. So a lot of the problem with those type of garments or textiles in the industry at the moment is that that coating often wears off, and that's where users get annoyed with like the waterproof performance and water repellency. So they have to do things like recoat the textile. And then once you do all those things, you go through all these cycles, it eventually wears down the material. So yeah, we don't rely on that at all. So we can just eradicate that whole problem.
Yeah, exactly. So your performance doesn't dip over time. That nice thing with a brand new waterproof jacket, the water beads up and rolls off really nicely. And then in 2-3 years, it washes off gradually, and things like your rucksack rubs it off. But that also leaks out during its production, not only its use, but also in landfill as well. So those chemicals that are used are a family called as PFAS, and they're coming out as being banned, particularly in the US, but also in the EU as well. So the outdoor industry right now is looking at different types of chemical compounds that can be used as coatings for everything from tents and jackets, anything you want to be water repellent. So our idea is to completely sidestep that problem and not use any coating at all. Because those PFAS compounds that we're talking about are a family known as forever chemicals, which means they bioaccumulate in the environment and they'll never break down in nature. They're just out there. You won't be able to see them, but those polymers will be there. So that's the main reason that Amphitex is different. But the second thing, I think the main point was sustainability, and you talk about longevity. I think when most people think about longevity, they think of the actual product itself. But from a material point of view, longevity is from literally creating the raw material all the way until landfill or incineration, which is where, surprise, most of your products, particularly textiles, will end up. So we talk about longevity, we're talking about closing the loop and having a circular economy in which you take responsibility from the raw materials, literally the conception of the idea, all the way until the end of its life, and then reusing the fundamental material, not reusing the product and not downgrading it or downcycling it as it's commonly called, but actually reusing the material. So the other aspect for us is recyclability and reuse, not in the product, but in the materials. So most waterproof breathable textiles are made of 3 different layers: an outer woven fabric, an inner membrane that's porous, and that allows it to be breathable, and then some sort of inner protecting fabric or some sort of layer of insulation. Normally, those 3 layers are laminated together, and they're all made of different textiles. So imagine you're recycling at home. You can't recycle some stuff with other things. If they're glued together, though, in the case of these textiles, you can't separate them, and that's why they end up in landfill or in incineration. And when you burn those chemicals, which often does happen, what happens is things like PTFE are releasing toxic fumes. So PTFE is a really common polymer that's used for things like membranes and waterproof jackets. So it becomes an intrinsic problem there. And our solution is to create all three of those same layers. So it's the same construction and the same performance as existing waterproof breathable textiles, but making each layer from the same polymer. And that's the polymer that June first was looking into and designing an artificial gill with. So that's the link between the two. It's all about using that same hydrophobic and breathable polymer in different constructions to make these different layers and deliver a fully recyclable textile, but then also a fully, say, recyclable jacket or set of gloves or whatever. So those are the twofold real innovations that Amphitex is using. The lack of coatings, but also being a fully recyclable system. And it's that monomaterial structure, we call it.
I am completely blown away by this because you've raised so many valid points. And I think within the fashion industry, just as a whole, this series isn't about fashion so much as it is tech, but they work together. And I think there's been so many innovations in the textile space, especially, that then enable us to look at further changing the production and how we make clothes. And I speak to so many brands who say things like, oh, it's really difficult actually to make a completely biodegradable or completely recyclable product. But it's because they don't have the ingenuity there to do it. So it's just like you've got the engineering, you've got the skills to then develop this new product and looking at ways that you can use something that was designed for one thing and applying it to something else. Because standardly, if you look across like most suppliers in the fashion industry, let's just say for shirts or like normal t-shirts and things, you can make a pretty much like 95% biodegradable or recyclable product. But it's things down to like the threads, the buttons, the labels that cause issues because so many, especially labels, are made of a polyester-based material and that can't biodegrade or recycle. So it's really, really fantastic that you guys are working to create something that is completely like full circle and a circular product as well, which is just phenomenal.
What you mentioned about the different components and things like that, all the stuff that goes into making, like, for example, just a jacket. It's a good point. Like a lot of those things have to be taken apart. So there's like the disassembly aspect of it as well. And I think with us, what we're trying to do is kind of a bit of everything. So we're developing the fabric, but also trying to maybe create guidelines or something like that and pass that on to people who'd be using it to then turn it into garments to say, we're making the material out of this. Maybe we should use a range of specific materials to then make the components. Or, yeah, we're trying to design the whole system, not just one aspect of it. And I think that's where a lot of brands or people who are in the industry now struggle because they're having to like retrospectively fix all these things that have just been put in place already for however many years. Yeah, it's like something that they have to go back and fix.
I think often it's very rare that there's a fundamental technological barrier to a lot of these sustainability issues. It's often a behavioral change that's the main problem. So it's interesting in our scenario that we were able to solve this problem from a technical standpoint, and it wasn't from a case of trying to solve a textile problem within the textile industry. We've come from a background of, say, Deana's material scientist and myself in product design, and June is also a background in chemistry, coming up with a real material science innovation that then happens to solve the problem in the textile industry. So yeah, it's the transfer of the technology, and also going back to some of the biomimicry design aspects that we've included as well. Often the answers are already done for you in nature. You just need to look for how to use them and actually how to implement them in a mass scale, high volume, modern manufacturing supply chain. If you can work out how to do that with biomimicry aspects of design, that's the problem solved for you often.
Yeah, definitely. One thing that I want to ask, so Amphitex, it's a man-made fibre that is bioengineered to mimic something that's natural? Or am I understanding that correctly?
We get this question a lot, yeah. We find a big responsibility to be very specific, and sometimes it then can be difficult to explain exactly what we mean. Deana, I don't know if you want to explain that.
Yeah, sure. Yeah. So you're right. We're using like a synthetic polymer, so it's man-made. The bio aspect can be quite confusing because people typically associate that with maybe like a biomaterial or something natural or something that will degrade. We are taking this synthetic approach purely because of the certain properties that we need the fabric to have. So like waterproof jackets, people expect really high specs from these kind of materials. And right now it's not really there with using natural fibers. So instead we're still relying on something synthetic, but just trying to make that as sustainable or as simple as possible. So we're not using different materials and things like that. Mm-hmm. But yeah, the biomimicry comes in more so to do with like replicating some of the things that you get in nature that will repel water. So like if you go down to the micro or nano scale level, a lot of ways that various surfaces can just repel water easily, like the lotus leaf is a good example, will just be to do with like surface roughness or surface structure. So it's like not using any chemicals or not using anything specific. It's just using the material and how, like, the geometry that it's in, and that will give those kind of hydrophobic properties.
Yeah, there's absolutely a lot of buzzwords that get thrown around, like biodegradable and bio-based. And for instance, bio-based can mean different things in different parts of the world. So you only need a really small percentage of bio-based materials to be considered a bio-based polymer, for instance, in Europe, but that's different in America. And that's one of the problems. There's not an equal representation of it around the world. And the big difference, again, between things like recycled and recyclable, like, for instance, there's a lot of textiles that are made of, and a lot of new ones coming out actually, made of recycled, say, polypropylene and recycled polyesters. But often you're downcycling a material into a product that's then probably a composite that then cannot be recycled. So it's good in the sense that you've elongated the material lifespan by one cycle, but it's absolutely not circular. And often, in our case, with waterproof breathable textiles, they're often laminated together with glues. Those glues can often be different compounds as well. And like we said before, coatings. So it's a real minefield out there. And that's why we're trying to have one solution for all of those things. And that is just to use one polymer for the entire construction. The aspects of biomimic, though, are really interesting, I think. And the aspects of things like structural color can be an interesting one as well. So looking at how we use dyes, and do we even need dyes? If you can, for instance, things like iridescent effects in nature, particularly in things like butterfly wings, you don't actually need pigments to create, say, some of those really vivid blues that you see in nature. And instead, that's just the way light interacts with surface. And going back to what Deana said about structural hydrophobicity, a similar thing can be done with color and light interactions as well. So there's a lot of solutions out there already that exist in nature. It's just about how we can mimic them.
I loved what you said there, because there is a big disparity with labeling in the sense of how terminology is used. And across the board, there's, as you said, it only has to have a very small percentage of bio material in it for it to have the name. It's the same with any sort of labeling system when it comes to organic and things like that, and different certifications. So I think with you putting out documentation with the materials, telling different suppliers how to use it, that will then invoke some sort of change. I was wondering, do you apply like life cycle analysis to your products? And what impact, if you do this, has it had on reducing waste and the environmental impact?
It's actually one of the things we're tackling at the moment. It's a bit of a chicken and the egg situation for us, because we have been doing sort of 2 years of R&D on the textile. It has been a startup story. We didn't have a high volume manufacturing supply chain. We weren't selling the textile. We're hoping to commercialize it this year. That's what we're really focused on at the moment. And as part of that big drive in the sort of the first couple of quarters of this year, we're going to be doing our life cycle assessment of the supply chain, because you need to build one to improve it, but you also don't want to build a bad one. You want all that information up front. So we're actually working with a couple of different organizations at the moment to make sure we have third parties involved with our LCA, not only to get their expertise, but also to validate lots of the claims and calculations we're making. So at the moment, we're in the process of gathering a lot of metrics on the processes that we do, so that we can hopefully identify the best places, not necessarily in the world, but geographically, and also the best factories, because there's a huge disparity out there between even just comparing different manufacturing processes, different parts of the world, different companies that do or claim to do very similar things. How they do that is a huge thing, particularly in the textile world, because as you know, manufacturing for textiles happens, internationally, and it's really difficult sometimes to monitor and validate lots of those claims. So we're actually in the process of that at the moment, and hopefully that will improve Amphitex's overall carbon footprint.
It's just a challenge that we're facing at the moment, because the material, the polymer that we're using is not something that's currently used in the textile industry. So it's about gathering that data first. And it's something that we have to do from scratch a little bit, to be honest. But yeah, we're currently in the process.
With regards to like the new materials, and as you said, there's nothing else out there like this. Are there any other sort of materials or like cutting edge, innovative things that are going on, maybe whether it's science or biotechnology innovations that you're exploring to reduce waste, I'd want to say, and maybe increase sustainability across other areas in need? So maybe not for waterproofs, maybe just if there were other areas that needed innovation, is there something that you could talk about?
Yeah, I think something that is across textiles, for example, what we're looking at is trying to, a way of colouring our material, for example, because every brand will want a certain range of different tones or colours. So typically those are done through like water-based dyeing techniques. So it uses like a really high level of water to be able to dye those kind of fabrics. And right now we're trying to go away from that. But there are cool things that we've stumbled across so far in our development process, like using CO2 dyeing, or just different ways of doing textile finishing. That's something that's quite quite a big field at the moment.
Could you just explain a little bit about the CO2 dyeing? Because that's quite a new innovation, isn't it?
Yeah, it's essentially a way of introducing pigments into, it can be fabrics or various different materials or forms, but just using like pressurized gas essentially. So using that gas as the carrier rather than water. And right now, I think that there's a startup company, or I think there are a couple of companies doing that at the moment, and they're just looking into, just assessing the metrics or sustainability metrics associated with that at the moment.
Separation technology is used in many industries, not just textiles. So there's some really harmful chemicals that are used in membranes, and often it's a really similar problem to what we've seen in the textile industry, in that performance is the one metric that matters. And now we're seeing just so much more innovation in the fundamental material science that we can't really scale up fast enough at the moment. We'd really like to do more R&D in a lot of different aspects, particularly with the gill as well that's ongoing. But that's a whole other kettle of fish.
I think a big one for us is looking into medical equipment or materials that be used in medical applications as well, because there's a lot of similar qualities that you'd want from the material that we're using in waterproof textiles, for example, that would translate really well into the medical field too. So things that can repel water, or even going into like sidestepping into medical textiles as well, like surgical gowns and things, you need all those same qualities too.
Yeah, those are all synthetic textiles that it also helps that they stay clean, but also there's a huge single-use market in non-woven and woven textiles for medical applications. So it's something that, we definitely believe, I think our textile and expertise in the team would lend itself really well to. We're just trying to get Amphitex out there first.
My final question for you is about renewable energies. So how are Amphico sort of utilising renewable energies and energy efficiency sort of protocols to reduce your carbon footprint and improve sustainability in the production of Amphitex?
Energy efficiencies is the main one there for us. Obviously, we can build a supply chain, and absolutely, if factories are using renewable energy, that's a massive reason for us to work with them rather than others. At the moment, that's a lot of the work we're doing with our, like we said earlier, with the LCA analysis that we're doing. We'd really like to be working with factories that have those metrics, that follow their own set of principles and guidelines. There's a lot of different certifications out there, particularly in textiles, but also, B Corps and Blue Sign and all those types of things. But energy efficiency is the big one. For instance, we touched upon dyeing textiles earlier. Dope dyeing is a much more efficient process than traditional textile dyeing. Dope dyeing is becoming more and more common in synthetic textiles, where you actually add the pigment into the master batch of polymers, and then in the extrusion process, it becomes embedded in the textile itself, rather than making a woven textile and then dunking it in a big bath of dyes. But then you have a lot of waste, and it takes a lot of energy as well, and water footprint. So when you say energy efficiencies, there's a lot more there than just power and electricity. Things like water and CO2, and also chemical footprints are a big one, because you can use hazardous chemicals, toxic chemicals, and still have an energy efficient process, or be using renewable energies in your factory. And it's great to have one, but not without the other. So it's about having a greater appreciation for the bigger picture and being responsible for all of the outputs and inputs in your processes that are obviously a combination to make your raw material into a final product, and then take responsibility for the final product as well at the end of its life, rather than just looking at something like renewable energies. That's a small focus in a much larger lens.
Okay, wow, what a conversation. I really enjoyed that. I don't know about you guys, but I really did. So thank you so much to Fergus and to Dr. Deana. I definitely think that the benefits of science and sustainable tech solutions cannot be overstated. As the world is kind of facing increasingly urgent environmental changes, science and technology have proven to be really, really powerful tools in combating that climate crisis. From renewable energy to sustainable fashion, the innovations created by scientists and entrepreneurs are making it possible for individuals, businesses, and governments to adopt more sustainable practices. In next week's episode, we'll be doing a deep dive into the world of clean tech. Until then, you can subscribe and listen back to previous episodes of Sustainably Influenced on all good podcast platforms. You can follow @Sustainably Influenced on Instagram and TikTok. I'm Bianca Foley. Thank you for listening. This season of Sustainably Influenced was produced by Content is Queen, sound editor Amber Miller, research assistant Toyo Douglas, and presented by Bianca Foley.